laws of indices. In today's lesson, we will be looking at the different laws of indices. So the first one we are going to be looking at is multiplication. So let's have a look at the background of looking at problems with indices and multiplication. So the first one we're going to be looking at is 2 to the power of 4 times 2 to the power of 3. Okay, well, 2 to the power of 4 means 2 times 2 times 2 times 2. You multiply 2 by itself 4 times. The times here, and 2 cubed means 2 times 2 times 2. Okay, well, how many times have we multiplied 2 by itself? Well, we've multiplied 2 by itself 1, 2, 3, 4, 5, 6, 7 times, so 2 to the power of 7. And as you can see, when we multiply, we can just add the powers together because 2 to the power of 4 times 2 to the power of 3 means we are going to be multiplying the number 2 by itself 7 times. Let's have a look at another example like that. So let's do 5 to the power of 6 times 5 to the power of 5. Okay, so 5 times 5 times 5 times 5 times 5 times 5, that's 5 to the power of 6, multiplied by 5 to the power of 5, 5 times 5 times 5 times 5 times 5. Well, how many times have we multiplied 5 together? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. And you can see we could have just done 6 out of 5 to get 11, 5 to the power of 11. Okay, so when we multiply, you keep the base the same, which is your number that you started off with, and you add the powers together. Okay, so for example, we could have 3 squared times 3 to the power of 7. Well, rather than writing all that out, we can just keep the number 3 there. Well, 2 out of 7 is 9, and that's it. We leave the answer like this. There's no need to work out what 3 to the power of 9 is. You just leave your answer in indice form as it is. Okay, you could also have 4 to the power of 15 times 4 to the power of 20. So you keep that the same. The base is the same, you just add the powers. 15 add 20 is 35, so it's 4 to the power of 35. Okay. When we are dividing, let's have a look at what happens. So we've got 5 to the power of 5 divided by 5 squared. Well, 5 to the power of 5 means 5 times 5 times 5 times 5 times 5. Divided by 5 times 5. Well, we need to cancel some out because 5 divided by 5 is 1. 5 divided by 5 is 1. And obviously when you times anything by 1, it stays the same. So we're just left with 5 cubed. And what do you notice this time? Well, we notice that the difference between the powers is 3. So when we are dividing, we subtract the powers given that the base is the same and the base here is 5. Okay. We could have 10 to the power of 7 divided by 10 to the power of 4. So let's have a look what that would be. 10 to the power of 7 is 10 times 10 times 10 times 10 times 10 times 10 times 10. Let's check. 1, 2, 3, 4, 5, 6, 7. Divided by 10 to the power of 4. 10 times 10 times 10 times 10. And let's cancel. 10 divided by 10 would be 1, 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 which is 10 cubed. Okay? Lovely. Right. That is division, so we can just subtract the powers. So again, 7 take away 4 would be 3. So we could have something like 15 to the power of 9 divided by 15 to the power of 7. That would be 15. All we do is 9 take 7, which is 2. 15 squared. We could have 100 to the power of 7 divided by 100 to the power of 3. Again, that would be 100, and you just subtract the powers. 7 take away 3 would be 4. Lovely. Okay, let's have a look at some examples then. Some slightly tricky examples to do with multiplication and division. This time, let's p to the power of 6 times p to the power of 7 times p to the power of 3. Now, you don't always have to have numbers. You can have letters as well. So it would be P. Now look, we've got times and times, so we can just add the powers. 6, add 7, add 3. Okay, that would be 16. The answer is P to the power of 16. We could have something like this. 4 squared times by 4 to the power of minus 3. Okay, again, it'd be 4. And look, we've got a multiply. When we have a multiply, it means we have to add the powers. We've got to do 2 add minus 3. Now think about this very carefully. When you have a positive and a negative, what does it make? It makes a negative. So we're going to do 2 take away 3, which is minus 1. So slightly tricky and slightly more complicated. You're still adding, but it just means because I've got a negative number, I've ended up subtracting instead of adding it. Okay. Number 3, we could have something like 5 to the power of 8 times 5 to the power of 4 times 5 to the power of 9. Okay, again, we just add the powers. So I do 8, add 4, add 9 to get 21, 5 to the power of 21. Okay, I can also have, let's do 7 to the power of 15 times 7 to the power of minus 2 times 7 to the power of minus 7. Slightly tricky. So number 7 stays the same and we add the powers. So I've got to do 15, add minus 2, add minus 7. Right, it's a bit silly having this add and minus 7. Well, add and a minus, or a positive and a negative make a negative. And a positive and negative make a negative, so that becomes subtract. So I've got to do 15, take away 2, then take off 7, which is 6. So your answer would be 7 to the power of 6. Okay. We could also have something like this. Okay, number 5. We could have d to the power of 3 divided by d to the power of 4 divided by d to the power of 5. Right, it's going to stay as d, and we just subtract the powers. 3 take away 4, then take away 5. So 3 take away 4, then take away 5 is minus 6. The answer would be d to the power of minus 6. Okay, let's do another example like this. We could have e to the power of minus 2 times by e to the power of 5 divided by e to the power of 2. Right, take it a step at a time. This bit here, because it's a times, you add the powers. So I do minus 2 add 5, which is 3. So that there would be e to the power of 3. Now I'm going to do divided by e squared. So the e stays the same because it's a divide. I've got to subtract the powers. So 3 take away 2 is 1. Well, I don't really write the power 1, do I? So it's just e on its own. One last one like this. 7 to the power of 10 divided by 7 to the power of 3 times 7 to the power of 4. Right, do it a step at a time. Divide means subtract the powers. So 7 is going to stay the same. 10 take 3 is 7. And then times by 7 to the power of 4. And then because that's a multiply, you add the powers to get 11. Lovely. Okay, let's have a look at another law of indices. We've done multiplication and division. The other law is to do with brackets. Now, 3 squared all to the power of 3. Now, we've got 2 lots of indices here. Now, 3 squared obviously means 3 times 3. And that means I've got to cube 3 times 3. So 3 times 3 times 3 times 3 times 3 times 3. That is what that means, okay? Because 3 squared is 3 times 3, and then I've got to cube it, which means I've got to multiply that by itself 3 times. Well, how many times have I multiplied 3 by itself here? 1, 2, 3, 4, 5, 6. 3 to the power of 6. And what do we notice about the powers? How can we get the number 6 from 2 and 3? Well, we multiply the powers when we have a bracket. Let's have a look at another example like this then. Okay, let's have a look at, we'll do 4 to the power of 3 to the power of 5. Okay, so again, 4 cubed means 4 times 4 times 4, 4 times 4, sorry. 4 times 4 times 4. And I've got to times that by itself 5 times. So 4 times 4 times 4 times by 4 times 4 times 4 times by 4 times 4 times 4. That's 3 times. That's 4 times. And that's 5 times, okay? How many times have I multiplied 4 by itself? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, 4 to the power of 15. And you can see we can do that by doing 3 times 5, which is 15. So the base stays the same and we just multiply the powers. So for example, I can have 10 squared cubed. Well, 10 stays the same and you just multiply the powers. 2 times 3 is 6. 7 to the power of 4 to the power of 5. Again, 7 stays the same and you just multiply the powers. 4 times 5, which is 20. Again, you might have something like this. A to the power of 2 to the power of 11. So again, A stays the same and you just multiply the numbers. 2 times 11 is 22. And that is your rule for brackets. So when you have brackets, you multiply the powers. Another rule is anything to the power 0 is always 1. Okay, so for example, 2 to the power of 0 would be 1. 3 to the power of 0 would be 1. 100 to the power of 0 would be 1. X to the power of 0 would be 1. S to the power of 0 would be 1. Anything to the power of 0 would be 1. Even if you had 2.452 to the power of 0, that would also be 1. Okay, so anything to the power of 0 is always 1. Right, let's use the different laws that we've just learned now to make the problem slightly more complicated. So this time, what if we have 5a to the power of 4 times 3a squared? Well, that here means 5 times, well, a to the power of 4, which is a times a times a. I've then got to multiply it by this, which means 3 times a times a. Now I can simplify this because I can do 5 times 3, which is 15. And then how many times did I multiply a by itself? 1, 2, 3, 4, 5. So a to the power of 5. And you can notice that we just times the outside numbers together to get 15. And then obviously the a to the power of 4 times a to the power squared we've already learned above is when we have a multiplication. The same base, what we do is we add the powers. So 4 add 2, that is incorrect. It is not 5, is it? It's 6. Oh, and that's because I have missed out an A there when I was writing it, and that works now, doesn't it? That is 6. There we are. Always be careful. I did 5a cubed there rather than 5a to the power of 4. Let's have a look at another one then, like that. Let's do 2x squared times 3x 4. Well, 2x squared means 2 times x times by 3 times x times x times x times x. Let's double check. 1, 2, 3, 4. 1, 2. Lovely. 2 times 3 is 6. How many times did I multiply x by itself? 1, 2, 3, 4, 5, 6 again. So x to the power of 6. And you can see I times the numbers on the outside. 2 times 3 is 6. The base stays the same. And 2 add 4 is 6. Okay. So what if we had something slightly different then? Let's say I had 5a cubed times 2a 10. So I would times the numbers on the outside. 5 times 2 is 10. A stays the same base. I've got a time, so I'm going to add the powers. So 3 add 10 is 13. I could have 5d squared times by 3d5. So again, 5 times 3 is 15. D stays the same. Add the powers because it's a multiply. 2 add 5 is 7. I can have something like 4 x squared times by 3x to the power minus 2. So again, just multiply the numbers. 4 times 3 is 12. X, and then obviously it's a time, so I add the powers. I do 2 add minus 2. However, 2 add minus 2 makes 2 minus 2, which is 0. Right, we have a bit of a problem here because x to the power of 0 is 1, so that becomes 12 times 1, which is just 12. Okay, so we're using quite a few laws of indices here to answer the questions. We can have something like this. 10a to the power of 4 divided by 2a to the power of 2. Right, 10a to the power of 4 means 10 times a times a times a times a divided by 2 times a times a. Okay, right, first of all, we can cancel some of the a's because a divided by a is 1, a divided by a is 1. I can do 10 divided by 2, which is 5. And how many times are we left with? A is a times a, which is a squared. So look, we can do 10 divided by 2, which is 5. And obviously we use the same rule as we've learned above before. When you have divide and you have the same base, you subtract the powers. 4 take 2 is 2. Okay. So let's have a look at 8a try 6 divided by 4a to the power of 4. So the first one means 8 times 8 times 8 times 8 times 8 times 8 times 8 divided by 4 times 8 times 8 times 8 times 8. Right, well, 8 divided by 4 is 2. A divided by A is 1. A divided by A is 1. A divided by A is 1. And A divided by A is 1. And then we're just left with A times A, which is A squared. So again, I did 8 divided by 4, which gave me 2. And then we've got divide, the same base. So we just subtract the powers. 6 take away 4 is 2. So what if I had something like this then? I can have 30x4 divided by 15x3. So I will divide the numbers. 30 divided by 15. Yeah, we can do that. Is 2. X stays the same and subtract the powers. 4 take 3 is 1. So that's 2x. I can have something like this. I can have 88 T11 divided by 8T6. So 88 divided by 8 is 11. T stays the same. I've got to do 11 take away 6 now to give me 5. Okay. Question number 3 then, similar to this. I can have, let's do 270x to the power of minus 4 divided by 3x to the power of minus 2. Okay, so 270 divided by 3 is 90. X stays the same. I subtract the power, so I do minus 4 minus minus 2, but that becomes a plus. So minus 4 add 2 is minus 2. Okay, so again, number 4. What if I have something like this? 5d squared times 3d 4 times 6d7. Again, times the numbers together. So 5 times 3 times 6 is 90. D, and then you just add the powers. So I've got to do 2 add 4 add 7 is 13. Question 5, we can have something like this. 88g15 divided by 11g squared divided by 2g4. Divide the numbers. Well, 88 divided by 11 is 8, and then divided by 2 is 4. G there, and then just subtract the numbers. 15 take away 2 take away 4 is 9. Okay, what if we have something like this now? 420 x to the power minus 4 divided by 6x squared, and then times by 3x10. So this is where you've got to do it in parts. So this one here, I've got to do 420 divided by 6 first, which is 70x. Because it's a divide, I've got to subtract the powers. Minus 4 subtract 2 is minus 6. Then bring that down, times by 3x to the power of 10. Well, 70 times 3 is 210x. And then because it's a multiplication, I've got to add the powers. Minus 6 add 10 is 4, and that is your answer. You do it in parts. Let's have a look at another question like this that we have to do in parts. 24 P10 times by 32 P11. Divide that by 4 P20. So do it in parts first. So I've got to times the numbers. 24 times 32 is 768p. Add the powers because it's a multiply. So that's 768p to the power of 21. Bring that down, divided by 4p20. So 768 divided by 4 is 192p. Subtract the powers, 21 take away 20 is 1, so it's just 192p. And there we are. Okay, that was laws of indices.